Good afternoon students. Welcome to your mathematics class. Today in this video we will learn about the chapter factorization. Now factors of natural numbers. When a natural number can be expressed as the product of two or more natural numbers, then each of these numbers is called a factor of the natural number. For example, we can write 6 as 2 multiplied by 3 because we know 2 3s are 6, and also we can write 6 as 1 multiplied by 6. So here 2 and 3 are called factors of 6 because the product of 2 and 3 is 6. Also 1 and 6 are the factors of 6 because their product is also 6. So therefore, all possible natural numbers factors of 6 are, what are the possible natural number? Natural numbers factors of 6, that is 1, then we write 2, then 3, then 6. So these are the possible natural numbers factors of 6. Now in other words, we can also say that 3 is a factor of 6 because 6 is exactly divisible by 3 without leaving any remainder. 2 is a factor of 6 because 6 is exactly divisible by 2. So we can say that a factor of a number is an exact divisor of that number. So factor of a number is an exact divisor of that number. Here 1 is a factor of every number because we know that every number is exactly divisible by 1. For example, 6 is divisible by 1, 7 is divisible by 1. So every number is exactly divisible by 1, or in other words 1 divides every number exactly. So 1 is a factor of every number. And also every number is a factor of itself. So every number is exactly divisible by itself, or every number divides itself exactly. So we can say that every number is a factor of itself. For example, 6 is exactly divisible by 6. So every number is a factor of itself. Now let's see another example. 30 can be written as 1 multiplied by 30, 2 multiplied by 15, 3 multiplied by 10, 5 multiplied by 6. So here we can write 2 divides 30 exactly. So 2 is a factor of 30. 15 divides 30 exactly. So 15 is a factor of 30. 3 divides 30 exactly. So 3 is a factor of 30. Similarly 10, 5, 6. These are all factors of 30. Also 1 and 30 are factors of 30 because we know 1 divides every number exactly and every number divides itself exactly. So from this we can say that the all possible natural numbers factors of 30 are, first we write 1, then 2, then 3, then there is 5, then 6, then here the next number is 10, then 15, and then 30. So these are the possible natural numbers factors of 30. So we can say that if A divides B exactly, then A is a factor of B and B is a multiple of A. So 3 is a factor of 30 and 30 is a multiple of 3. If 2 is a factor of 6, then 6 is a multiple of 2. Now prime factors, we know that a factor which is divisible by 1 and itself only is called a prime factor. So a number can be written as a product of prime factors is said to be in the prime factor form. For example, we can write 30 as 2 multiplied by 5 multiplied by 3. So here 2, 5, 3 are prime numbers. So we can say that 30 is equal to 2 multiplied by 5 multiplied by 3 is in the prime factor form. So here 2, 3 and 5 are the prime factors of 30. Example 72. We can write 72 as 1 multiplied by 72, 2 multiplied by 36, 3 multiplied by 24, 4 multiplied by 18, 6 multiplied by 12 and 8 multiplied by 9. So all natural number factors of 72 are 1, 2, 3, 4, then 6, after that 8, 9, 12, then 18 is there, 18, then 24, then 36 and at last 72. These are the all natural numbers factors of 72. Also we can write 72 as 2 multiplied by 2 because 8 9s are 72, so 8 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. These are all prime numbers. So 72 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 is in the prime factor form. So from this we can write, so 2, 2, 2, 3 and 3 are the prime factors of 72. Factors of algebraic terms or factors of monomials. When two or more numbers or variables are multiplied, then each one of them is a factor of the term or monomial. A term may have any number of factors. The constant factor is called a numerical factor, while a variable factor is known as literal factor or algebraic factor. For example, 5xy can be written as 5 multiplied by x multiplied by y. So here 5, so therefore 5, x and y are the factors of 5xy. So 5 is called the numerical factor and x and y are the variable factor, or we can say algebraic factor. Now, what is irreducible factor? In algebraic expressions, we use the word irreducible in place of prime. For example, 2xy can be written as 2 multiplied by x multiplied by y. So 2 multiplied by x multiplied by y is in the irreducible factor form of 2xy. Since the factors 2x and y of 2xy cannot further be expressed as a product of factors, so 2x and y are the irreducible factors of 2xy. Let's see another example. Here 2 multiplied by x square y is not an irreducible factor form of 2x square y, since the factor x square y can be further expressed as a product of x and y. That is, x square y can be written as x multiplied by y. So 2 multiplied by x multiplied by x multiplied by y is in the irreducible factor form of 2x square y. Therefore 2x, x, y are the irreducible factors of 2x square y. So factors of algebraic expressions. When an algebraic expressions can be written as the product of two or more algebraic expressions, then each of these expressions is called a factor of the given expression. So when we factorize an algebraic expression, we write it as a product of factors. So these factors may be numbers or algebraic variables or algebraic expressions. So the process of writing an algebraic expression as the product of two or more algebraic expressions is called factorization. Or in other words, we can also say that the process of writing an algebraic expression as a product of its irreducible factors is called factorization. So factorization is the reverse process of multiplication. For example, here the product 2xy is written. So this can be easily written as 2 multiplied by x multiplied by y. So here 2x and y are the factors of 2xy, and these are the irreducible factors. 2x and y are the irreducible factors of 2xy. So 2xy can be easily written as the product of its factors. Also 4x multiplied by x plus 3 can be also easily written as 4 multiplied by x multiplied by x plus 3. So it is given in their factors form. That means here 4x and x plus 3 are the factors of 4x into x plus 3. But here 2x plus 4 is not written as the product of their factors. So in this case, also in the second case, 3x square plus 6y also not given as the product of its factors. So in this case, we need to find the factors of this expressions. Let us do one example. Find the common factors of the given monomials, that is 18a cube and 27a square b. The irreducible factor form of 18a cube can be written as, we know 18a cube means 18 is 2 9s are 18. So 2 multiplied by 3 multiplied by 3. These 3 are prime numbers. Then a cube can be written as a multiplied by a multiplied by a. Therefore, the irreducible factors of 18a cube are 2, then 3, then another 3, then a comma a comma a. These are the irreducible factors of 18a cube. Now the irreducible factor form of 27a square b can be written as, we know 27 means 3 9s are, so 3 multiplied by 3 multiplied by 3, these 3 are prime numbers, and a square b can be written as a multiplied by a multiplied by b. So the irreducible factors of 27a square b are, so here 3 3s are there, so 1 3, then another 3, then another 3, then a comma b. These are the irreducible factors of 27a square b. So the common irreducible factors of 18a cube and 27a square b are, what are the common factors between these two expressions? See, here 2 is present, but 2 is not present here, so we will not write the common factor as 2. But next 1 3 is present here, so here we will write first 1 3, then another 3 is present, so we will write another 3. But there is no other 3, so we will not take any other 3. Now we come for the a. So here a is present. Second, another a is present, so we will take another a. But there is no b is present in the first expression. In the first expression, so we will not take any other variable. So in this way, we can see that the common irreducible factors of 18a cube and 27a square b are 3, 3, a. These are the common irreducible factors of these two expressions or these two monomials. Now, if it is asked that find the highest common factors of these two monomials or these two expressions, then in that case we simply multiply this irreducible common factors of these two given monomials. So for highest common factors of, if it is asked to find highest common factor, so highest common factor of 18a cube and 27a square b, we will simply multiply this common irreducible factors between them, that is 3 multiplied by 3 multiplied by a multiplied by a. So here we are getting 9a square, which is the highest common factor of these two given monomials. But here the question, find the common factor. So these are the common factors of the two. These are the irreducible common factors of this. There can be many other possible common factors between them, but these are the common irreducible factors of the given two monomials. Find the possible common factors of 18a cube and 27a square b. The irreducible factor of 18a cube we have just in previous problem we have done, that is 2 multiplied by 3 multiplied by 3 multiplied by a multiplied by a multiplied by a. Similarly 27a square b is also written like that. So here 2 3 3 a are the irreducible factors of 18a cube, and 3 3 3 b are the irreducible factors of 27a square b. So the possible factors of 18a cube are, from this factors we will write the all possible factors of 18a cube are, first we will write the numerical factors, as first we will write 1 because 1 is a common factor of every term. Next 2 is there, then 3. Now we will multiply them. 2 3s are 6, then 3 3s are 9. After that 2 9s are 18. So here we will write 18. 18 is also a common factor of 18a cube. Then next variable is there a. Then a multiplied by a square. Then If we multiply 3a, we get a cube. After that, each of this variable we will multiply with the numerical factor. So 1 is present in each of this factor variable. So we proceed with 2. So we write 2a, then 2a square, then 2a cube. Then we will write 3a square, then 3a cube. After that 6 is there. So 6a square, then 6a cube. Then 9 is there. That means 9a square, then 9a cube. After that 18 is there. So 18a square, then 18a cube. So these are the possible factors of 18a cube. Now come to the next. The possible factors of 27a square b. First we will write 1. Then there is 3 is present. After that 3 3s are 9. Then 3 3s are 9. 9 3s are 27. So these are the numerical factors. Then we will write a. After that a square. Then ab. Then a square b. These are the possible a multiplied by a square, a multiplied by b, a square b, and then ab. Now we will just multiply this numericals with the variable. So we get 3a square, 3ab, then 3a square b. Similarly 9a square, 9ab, then 9a square b. After that 27a square, then 27ab, then 27a square b. So these are the possible factors of 27a square b. Now the possible common factors of 18a cube and 27a square b are. So from this we have to write the possible common factor as 1 is present common to both the factors. Next 2 is not present, then we write 3. Then 6 is also not present, then we write 9. So we write 9. Again 18 is not present, 27 is also not present. Now if you see the variable, a is present in both the factors. So a, then a square is also present. So we write a square, but a cube is not present, ab is also not present, and a square b is also not present. So here 2 is not present, so we will not take this any of these factors. Again 3 is present, so we write all these 3 factors. That means we will multiply with this. That means 3a and 3a square we will write. Then 9 is present, so we write 9a and 9a square. Because these 2 variables are present here, so we will not consider the 6 also. We will consider only the 9a and 9a square. We will not consider 9ab and 9a square b. Also 18 is not present here and 27 is also not present here. So these are the possible common factors of 18a cube and 27a square b. Now in this common factors you can see the highest numerical value is 9 and highest variable value is a square. So the product of highest variable value is a square because the power of the a is 2, which is here more than power of a. So 9 multiplied by a, that is 9a square, which is the highest common factors of highest common factor of these 2 monomials. So therefore in this question it is asked here that find the possible common factors of these 2 monomials. So here we will write up to this. Now if it is asked that also find the highest common factor of these 2 monomials, that means 18a cube and 27a square b, in that case your highest numerical factor is 9 and variable factor is a square. So if we multiply, that means 9a square. So here HCF of this 2 monomial is highest common factor of 18a cube and 27a square b is 9a square. So in this way also we can easily find the highest common factor, but in this case the process is very lengthy and it is also taking lots of time. So better we use the irreducible factor form to find the highest common factors of the given expressions. So I hope all of you understood how to find the common factors of the given monomials or given expressions here. You try some questions which is given in your book. Thank you all of you.